Hi everyone. In this screencast I'm going to demonstrate how we use Microsoft Excel to draw scatter plots, and then we'll go a little bit beyond what the requirements of this question are, but we'll use this same data set to do so. So for this particular question, which we'll look at today, we're drawing a scatter plot. Now that's just a little image that I captured from the PDF textbook page. So I needed to enter this data into Excel cells. I typed the label, height in centimetres and shoe size, and then I've typed each of the numbers as I was going. Once you have that done, then highlight the two columns with your data, not the labels, just the numbers. On the ribbon we go to Insert, and then we choose this one here, which is an XY scatter plot, and I select this one just with the dots, and that's my scatter plot right there. I'm going to make this title a little bit more informative than just a chart title. So this is about how tall different people are and the size of the shoes they wear. So let's take something like shoe size for various heights people. I'll use the plus button here in the corner to add axis titles. Now, it's very important that we label these correctly. The first column, which is height, that ends up being the x-axis by default, and the second column, shoe size, is the y-axis. We can match the numbers here. We've got numbers from about 4 up to 12, that's those, whereas these numbers in the hundreds are down here. So this one is shoe size. If I click on that one, I think I can start typing height. And this one does have units of centimetres, so don't forget to put the units there too. Now, that's all that's really required for question number 2. I don't like all this blank space here on the left-hand side. The default for Excel is to go from 0 up to a bit beyond the largest number. But I really don't need all that. If I do a right click on the axis here, I can format that, and I don't have to have a minimum 0. I could make that about 140 for the minimum, and you see how that makes it a much more presentable graph. In fact, the maximum doesn't even have to be 200. It could be a bit less, but that's not too bad to have that. Oh, I might make the maximum 190. And so that's making pretty good use of my data. I don't mind a little bit of blank down there. Now, that's as far as question 2 is concerned. But what if I wanted to add a trend line to this? So once again, if I use the little plus sign in the corner, I can tick the box for a trend line. The default choice is a straight line, which is fine for this one. It seems to be a pretty good match to what we've got. I can use that little arrow key to go to more options. Now, I could try different types of trends, but linear is the one that I want. And I'll also go down here, display the equation, and display the R squared value on the chart. Now that's just appeared here. It's a bit hard to read, so I'll increase the size of that a bit, and it's also a little bit, the background gets in the way a bit, so I'll put a little bit of light colour behind there to make it stand out. Now that's the equation of the straight line. We would recognise the number 0.1729 as the gradient and minus 22.005 as the intercept. So the intercept is way down on the negative. Remember, the 0 point for the scale is a lot further to the left because I changed the horizontal scale. Now, although it's nice to have those there, you can also calculate them. So I'm just going to put some text labels here. So I've got something to work with. Now those are just text. They don't actually do anything. The formulas that I'm going to use are going to go in the cells here beside. I start a formula in Excel with an equal sign, and for this one I want the slope of the line. You see how it tells me what to do? It says you highlight the no and y values. These are the no and y values. I type a comma and then it says give me the no and x values, that's these ones. Close the brackets. Now that number exactly matches what's there. The nice thing about that is that if I noticed there was a typo, say for instance that 150, I go back and check and it's actually 160, then it changes this, it changes the trend line, it even changes it up here on this one as well. So I'll just put that back to what it was, 150. Now, as far as C, the intercept, the formula is intercept. Again, it wants the y values first, a comma, then the x values, close the brackets, there's the intercept. Now this r squared, that's a little different. R squared is what we call the coefficient of determination, and this number tells me how strong the predictive power is for these two variables. So they're not perfect. If it was perfect, all of the dots would be on the exact straight line. The straight line is an approximation to what we're seeing here. So this height is sometimes called the predictor variable, and we can use this to predict values of shoe size, the response variable. So the 70.74 tells me that that's roughly how much of the change in response variable is controlled by the predictor variable height. So there's about 26% of the change that's due to other factors which we haven't captured, but 74% would be this is the most important factor in determining shoe size. The height of the person is an important factor. There's other factors which we haven't got available, but 0.74 is not bad. So that's a coefficient of determination. How do we determine that? Well, in Excel, I start typing. Now this one down here is correlation. Correlation is almost but not quite. So I'll put my y values, then a comma, and I'll put my x values just like I did before. I'll close the brackets. Now I'll put a few more decimal points on display. So 0.86 is not the same as that one, but that's okay. That's because correlation is not exactly the same as coefficient of determination. I can edit the formula by clicking up here in the formula bar. If I square the correlation, that's why it's called r squared. The squared correlation is the coefficient of determination, and so now that matches exactly. This is how we would calculate these things using formulas instead of just using the graph. Finally, I will have a predictor and I'll have a response. Now remember, the predictor is the horizontal variable height. What if I gave a new height? What if I said I have somebody comes into my shoe store and they're 200 centimetres tall? What shoe size would I expect for them? Well, I would use 200 as an x value in this formula, and I can calculate that. I would need the number 0.1729, which is stored here, multiplied is an asterisk, multiplied by the x value of 200, plus the intercept, which is stored here. And that gives me a shoe size of 12.57. Now shoe sizes go in whole numbers, so I'll reduce the decimals down to none. It'll round off to size 13. So I can use my linear model to predict. I can use the predictor of 200, the person's height, and the response variable, the shoe size. They would need probably a size 13 shoe. And now I've got about 74% confidence that that would work. There could be other factors where maybe they need a size 12 or a size 14. but about 74% of the time a size 13 shoe would tend to do the job. What if I had a person who was only 140 centimetres tall? Then it looks like they're going to need a size 2 for their shoe. That's how we use scatter charts and trend lines in Microsoft Excel, and we can then talk about the strength of the predictions that we're making here, and we can use a formula to calculate some predictions for numbers that we don't have. When I did those ones of a 200 and 140, we were going beyond the observed data. They would be extrapolating. If I wanted to say I had a person who was 168 centimetres tall, then I'm predicting using a prediction to get a size 7 shoe, and those are inside the observed data. That would be a interpolation. Interpolation is to look inside the range of data you've got, and extrapolation is to look outside what you've got. I think that's enough for one screencast. Thanks for watching.